At the end of this video, you will understand how to start a new project in Aspen OptiPlant and do the 3D modeling of equipment and structures using the standard library of Aspen OptiPlant. Aspen OptiPlant is a 3D conceptual design and engineering automation tool equipped with automatic interference-free pipe routing. It has been applied in EPC companies by saving project costs at the early stages of the projects, starting from FEL1, FEL2 through feed design stages. Aspen OptiPlant can help visualize, analyze, and optimize project data in a 3D environment. It allows us to create multiple layout options for analysis and decide on the most optimized option for cost, construction, safety, and operations. Aspen OptiPlant integrates with different industry standard tools to import and export the data for reusing the maximum amount of data. We can start by creating a new project folder in the local drive and naming it OptiPlant Test Project. Make sure that there are no spaces in the project folder name and the project path. Then, copy the files named Test Project Equipment List and Test Project Line List in the OptiPlant Test Project folder. We can type Aspen OptiPlant 3D Layout v12.1 in the search field and click the result to launch Aspen OptiPlant. After entering the Aspen OptiPlant main interface, go to File, Open. Then, navigate to the OptiPlant Test Project folder and name the file Test Project. This will be the plot plan layout file. Also, make sure there are no spaces in the file name. Then enter the plant name as Test, building name as Proj, and leave all the rest of the fields as default in the plot plan information form. Then click Accept. Aspen OptiPlant will open with a grid built-in top view. A tooltip displays the library of equipment, structures, and the names of all the equipment and structures when hovering the cursor. Next, we can build a pipe rack. Click the pipe rack icon and the grid. The parametric form for the pipe rack opens. We can name the ID tag EW main rack. Make sure there are no spaces. Then, enter the description as East-West main rack. Here, we select D1 as 50 feet. For D2 and D3, we can go to the Member Size tab and select the Pipe Rack checkbox to provide the member size for the column. Then we choose I-type and the member size as W12 by 27. Then go back to the Tag and Dimension tab, and we can see that the dimensions of the column have been updated. Next, enter 8 for D4, keep the spacing as uniform, and enter D6 and D7 with 1 foot. Then we can select 3 for the total number of levels, D8, give the rack ID for the first level with P1, the second level with P2, and the third level with U3. Keep the elevations as default and change the height for the first level to 1 foot and 0 inches, 2 feet and 0 inches for the second level, and 1 foot and 0 inches for the third level. In the type column, we choose P for the first level to make it a process level. Then select P for the second level and select U for the third level to make it a utility level. We can go back to the Member Size tab for the beam's depth and width, choose I-type for transverse beams, and provide the member size as W8 by 24. Similarly, for the longitudinal beam, we can select I-type and provide the member size at W8 by 24. We can also provide some dimensions for the bracing. Go to the Bracing tab, select the checkbox for Pipe Rack, then select the bracing pattern as diagonal. Keep Start From as 1, and change the day interval to 2. Here, we go back to the Member Size tab, choose I-type for bracing, and choose the member size as W6 by 12. Then, navigate to the Tag and Dimension tab, and we can see the dimensions of the beams have been updated. We can also position the pipe rack. Here, we enter 20 for the X and 90 for the Y, with elevation kept at 0. Set rotation as 270 east and select the orange color. Then click OK and click Accept. Now, the pipe rack in 3D is built successfully. Next, we can build a horizontal drum. Select the horizontal drum icon from the library and click the grid to open the parametric form. Here, we enter 41-F-9233_1 for the ID tag and enter Cooling System Expansion Drum for the description. Then we can set D1 as 7 feet and 2 inches and D2 as 28 feet and 6 inches for the dimensions. All the secondary dimensions will be automatically updated based on the primary dimensions. If the secondary dimensions are available, we can turn off this Auto Update Secondary Dimensions and fill in the secondary dimensions. Here, we will keep the checkbox selected. We can also give the coordinates. Here, we type 40 feet and 0 inches for the X, 130 feet and 0 inches for the Y, and 0 for the Z. Keep the rotation as 0 north, choose the yellow color, and click Accept to build the 3D model. To access Aspen OptiPlant in different views, we can go to the View tab. The model is in the top view by default. To see additional views, we can click Front, Right, and we can choose the ISO view to see the model in a free view. There are Zoom In and Zoom Out buttons to zoom in and zoom out of the model. To window around and zoom in for an area, we can click Rectangle and window around the area. Then it will be zoomed in. Then click Fit View to go back to the screen. We can use the scroll button on the right side or the center scroll of the mouse to zoom in and zoom out. Make sure the hand mode is selected, then press the center scroll button of the mouse to pan the model. To rotate the model, stay on the hand mode in the ISO view, then left-click to rotate the model.